Dr. Joe Long from UNC Wilmington. Joe's been here the last couple of years, and he's got some discussions about frying pan shoals, which I think we're all very interested in these days. It's quite an interesting system. So thanks, Joe.
I have pictures, don't have answers, probably less than 50 words on my slides, but a lot of pretty pictures. So I'm happy to be back. I appreciate the invitation. The first year I talked about tools we use to make decisions in coastal resilience and coastal science. Last year I told you about a project we were starting on frying pan shoals. I'll give you sort of the 10-second update on sort of that project. It's with the Bureau of Ocean Energy Management. In a collaboration with UNCW, and that includes 8 sampling periods on the shoals to sample the waves and the currents, the sediments, and then sort of the benthic environment, plankton, and fish that are both migratory and sort of housed on the shoals. And so there's 2 years of data collection, and so we don't know a whole lot, and so we get past that 2 years of data collection, but at least we get seasonal samples of how the shoals are used by these sort of the ecological importance of it. We'll be developing some models in the goal of helping to mitigate any risk should BOEM approve any future permits for sand use on the shoals. So that's kind of a 4-year process. It doesn't get us to that 40-year time scale. And so when Chris proposed this theme, I sat down with an undergraduate student of mine. Alex is a sophomore in our coastal engineering program. We said, what data could we pull that has 40 years of information in it? So what I'm going to show you today, Alex has worked on quite a bit, and it's pretty new. And like I said, no necessarily answers coming from this. Is it over? So what we chose to do is take satellite imagery from the past almost 40 years. I can only go back about 37 years. So what you see here is the shoreline at the shoals here identified from each of these satellite images. And so we have about 262 shoreline positions over the course of 1984 to 2021. And so we take these shorelines and we see sort of the ephemeral and dynamic motion that's happening here at the point from side to side. The date, it goes through here pretty fast. This is the mid sort of 2000s. And you see this shift side to side. We said, can we take this data and can we quantify something simple from this data that tells us how this subaerial part of the shoals has moved over time? So sort of amassed all of those, and those of you that live on the island or have been on the island for a really long time, you have seen a shift in that shoal, and you know it. You're like, well, in this year, I remember the shoal was out here. I don't know those things, so I'm going to look at the satellite image and just say, here is how we've seen the shoal evolve. The blues here are back in the 1980s. All the way up to the reds, those are in the most recent time periods of about 2021. And so we can visually see sort of how the shoal has shifted over that time period. So we want to know first, how has it changed in this 40-year time period? That might tell us something then about, doesn't suggest how that shoal might move in the future. Is there one consistent trend that the shoal has been moving over this time period that tells us how it might shift into the future? That's it. Of course you did. So I'm going to tell you sort of just our methodology. I'm going to tell you that this is sort of our really simple approach. Somebody asked me last night at dinner, how do we model sediment transport in the coastal environment? Sitting right there, and I said, well, my cagey answer to this is we first model the waves, we're pretty good at that. Then we model the currents, we're okay at that. And then we model the sand movement, and we're not very good at that because we're modeling individual sand grains and telling you how a beach evolves. So I sort of tend to sort of this simple approach first, the simple modeling, the empirical type modeling. So we took what we had, which were the shorelines, the dynamic shorelines that I showed you in that video. They're constantly moving. And then we took a static vegetation line. And this is just something we identified from the satellite image, one of the early ones, and said, we're going to keep those asterisks the same over this 37-year time period. We know the shoreline is changing. And so we're going to take a look at this polygon for every single of those 262 satellite images. And I'm going to look at a couple of things. I'm going to look at where the center of it is. So the center of that area. And then I'm going to look at how much area is there. How much beach, how much sand can I see over the course of time? So the center of it, that tells us where it might be shifting. And then there's just the sort of plan form area. So we took this approach and went through each of those satellite images over the course of sort of 1980s to 2021. The first thing we wanted to look at was just the movement of that center point. So this is the east-west movement. Think of this as our starting point. Anytime you see that line go up in that graph, it's moving more towards the east. Down, it's moving more towards the west. This is our north-south direction, where the center of that shoal is moving up and moving down. And we wanted to look at this first for trends. Right? We just want to understand, is there any consistent movement one direction or the other? I think you can look at these and say after sort of some time periods, we certainly see sort of a northeast movement. Makes sense from what we see in these satellite images, because you can see this shoal moving sort of up to the north and to the east. We can look at some rates here, look at the speed at which that is happening. But the one thing I sort of point your eye to is that it's not consistent over the entire time period. We don't have a single line that's going in this distance telling us the trajectory. I could stop right here, right, and tell you if there's one consistent line there, I could probably project that out to the future and say, here's where that might be moving. So it makes that picture a little bit more complicated. Then we took a look at area. So this is just subaerial, sort of what we can see from the satellite images in that shoal region that we've identified by the pilot. I'm going to move on from this and sort of, I want to describe something about the movement that you see here. But each one of these black dots is a shoreline from the satellite image where we calculated that area. This goes from that 1984 to 2021. And it's a little messy. The reason it's a little messy, I want to sort of think about this process of signal to noise. And in scientific applications, a lot of times we talk about a signal to noise ratio. What can we believe from data? Because a lot of times data comes in different forms, it has different resolutions, it's been collected by different methods. And so you can't use all data for the same purpose, if you will. So think about a situation where Beth and I are really close in a crowded room. You guys are all talking, but we're really close having a conversation. I can hear that signal really well. The noise is drowned out, right? So I can believe that signal versus when we're far apart. The signal between us, the thing I can hear is the same level as you guys talking. So I can't really believe that I understand the conversation that we're having at the time. When we think about satellite images, well, what do we think we can believe? And typically, we can't believe the day-to-day movement. Even if I have two satellite images back to back, look at how blurry this image is from the satellite. Each of these boxes represents 15 to 30 meter spacing along the beach. And so maybe I picked the shoreline here. Next day, it's 1 pixel over, but that's 30 meters away. But we didn't have 30 meters of shoreline erosion over the course of that day. So when I get back to this sort of graph of plan view area, I don't want you to focus on those individual wiggles because we don't believe those. Those are just noise. We want to pull out the relevant signal, the thing that we can believe from this. So from these satellite images and the shorelines that we define from them, can't believe day to day, probably can't even believe month to month, but I think we can believe year to year variations or these longer term trends. So I'll come back to this. And the first thing that stuck out to me is that there is a signal here that we can pull out from the noise, right? And so I'm going to draw that on top of here and say that from these satellite images, there are some pretty clear trends that are outside of this noise threshold of this day to day and month to month. And the other thing that struck me looking at this is that we have this trend from about 1984 till 2000 that is almost repeated when we get out here to 2007 out to 2021. In fact, when we quantify those rates, we think about sort of the level of noise, they are essentially equal. So during these two time periods, we had the same rate of change. How much area was decreasing per year was the same. So then we see this time period where we have an increase in area in that Plan View Beach that is 3 times the rate of erosion that we saw in these other time periods. And so I was sort of fascinated by this, that there's a pretty clear trend, that it changed in this kind of sawtooth pattern. And so back to this simplistic approach, I wanted to say, what might be explaining some of these trends, right? And sometimes we like to build a complex numerical model and throw it at it, but there are so many parameters or unknowns in that we tend to make them so complex that we just can't believe. So again, I'm going to take a really, really simple approach at trying to identify 3 main things that might be causing this. On this picture, there's more than 3. And how many years ago I don't remember, many years ago, 3, 4, 5 years ago, we made this figure Chris, Beth, myself, a whole bunch of other folks working on a proposal where we tried to say, let's put Bald Head Island on a map and identify all of the things that make it change. And this is what we came up with. And there's a lot on here, and trying to build a model for all of these things is really difficult and probably break my brain in trying to do it. And so what I chose to do is just identify 3 of these that I thought might be making the biggest impact on this shoal environment. So I'm going to focus on storms. Maybe there were difference in storminess between these 3 time periods. Maybe sea level rise. I hesitate to talk about it too much because Molly's in the room and she's far more of an expert on sea level rise than me. And then there's this sediment that we know moves along the beach with the longshore currents. And we believe there's what's called a nodal point on this beach where there's a divergence. And so sediment goes one way and the other way. Exactly where is that nodal point? We'll talk about here in a second. So those are the 3 that we sort of tried to identify. And we're going to dig in very surface level to try to see if they explain any of this. And when I was talking to Alex, I tried to tell him, he was getting really bogged down with how many decibels he had in some of his numbers. And I said, we're not gonna have any decibels in these numbers because this is an order of magnitude. Does this explain 10% of what we see? Does this explain 0.1% of what? Okay, there's a decimal. 1% of what we see, 10% of what we see. Order of magnitude is all we're looking for here to try to tell us what's most important. And then we can build something more sophisticated. So this is from our sort of Wrightsville sea level rise, or from the Wrightsville tide gauge, sea level rise of about 2.73 millimeters per year. We wanted to take this and say how much, right? If sea level is rising, maybe it's submerging some of this shoal, that would decrease the area over time. Really sort of simple answer to that though is we came out here last April and took some surveys of this subaerial portion while we were also putting some pressure sensors and current meters in the surf zone, thanks to Conservancy. That's one of those collaborative projects where they helped us and enabled us to be able to come and collect those data. So we have elevation. So we took a transect through here. So we know it sort of looks like a hump. And then we took sea level rise and said, as sea level rise comes up, how much area should still be visible as that rises? Probably, you're thinking about this, that's such a slow process, that 2.7 millimeters per year. That decreases this plan view area. It's a low sloping shoal. That explains maybe 7% of this rate of erosion in this plan view area that we see. Not the whole picture. I think we kind of knew that was probably going to be sort of this minor component in some of this trend. Plus, you could ask, this trend is continuing in one direction, and we saw something that was a sawtooth. So we knew it wasn't going to be the whole story. Then we tried to look at storms. And again, Alex, who wants to think about all of these individual components, it's like we got marred down in the details. And which storms impact Bald Head Island the most? Well, it's kind of a crapshoot, right? Size of the speed, the size of the storm, the speed of the storm, its location. So we tried to simplify and say, I don't know, maybe it's just the ones that make landfall. And from 1984 to 2021, there were those storms that we see there. Maybe it's those that are within a 10-mile radius, where the track is within a 10-mile radius. Maybe a 60-mile radius. So you see certainly the impact of storms or the impact of increased storms, depending on how we might want to define that. And then we took it one step further and said, okay, well, landfalling, we got that, but maybe it makes a difference if the storm track is on one side or the other. You can imagine that you are on the onshore wind side, where you're not on the onshore wind side, right? The storm passes over here, you might actually get winds pushing water levels away from Bald Head, versus a storm track here that has onshore winds onto Bald Head. So we separated this, and we used the 10-mile radius as that middle of the round road, the middle of the road. And this is the number of hurricanes. Green here are those that made landfall. Blue here that had a track west of the island, and red here is the track that had east of the island. So you know it, there are storms that impact the island. We can't necessarily predict when and where those will happen. I put on here our sort of general sawtooth pattern of what we saw in the erosion of the shoals. And I couldn't really make sense to say that these number of storms explained this pattern. So I don't have a percentage for you, but I would say this also is not the whole story. The last one we haven't gotten all the way through, and that's thinking about sand placements. And this is where Chris and I need to have lunch, so I can better understand some of this, but I took this off of the village's website. This is a summary of the nourishments that have occurred at along South Beach, and the colors here represent the project sponsor. And it's hard to see here, but there is a number in here in the volume of sand that was placed. And this line tells you how far it was placed towards the shoals. So I first looked at this and I said, oh, without a doubt, some of this sand went to the shoals, and maybe those years explain why we see an increase in the area at the shoals. So we went back to try to figure out where that nodal point was. Because I said, Alex, I bet it's like right here. And so there's only some of these that explain that. Not true. So we want to try to figure out how much sand makes it to frying pan shoals. The nodal point has been identified about this location on the beach, which is further to the west than I was originally thinking, and where most of the nourishments tend to reach. There still might be that the closer you get, more of that sand should be available and to go to the shoals. And so this is where Alex has been working on sort of a linear distance. So if we know the volume of sand and we scale it by a linear distance towards the shoals, we might be able to get a bulk number and how much of that sand should make it to the shoals. And I don't have that number yet, unfortunately. But I did put on here vertical lines where there were nourishments of about 1 million cubic yards or more. The bolded lines are the ones that are closest to the shoals. You'll notice that, yeah, if I plot this one, I would immediately say, yeah, there's an influx of sediment. Maybe that fed over time and created this. But we see similar nourishments of similar distances in this time period where we have this erosion. Do you remember when I said I had no answers? We're back to that. So these, at least in the way we've looked at them, these don't explain everything. We need to maybe dive into one of these a little bit more, whether it's the storm piece particularly, right? Storms are so individual and they impact an area so individually. And so whether we need to look at the waves or the water levels or something like that, same thing with this nourishment time period. I think those are the ones that we should dig into. But I promised something about the future. So I've zoomed out. This is the same data. I've just sort of made my axes longer so we can think into the future. And I made these axes longer so that I can draw out into the future a bit more. So same data. And I put in sort of, these were our rates of change that we see. So if we want to think about future, we see two opportunities here, right? One is we continue on this trajectory. I stopped it at 0. It's underwater, right? That point. I couldn't make these axes big enough to get out to 2062 with this increasing rate. And so identifying what it was that caused this, I think is really important, maybe to at least get you on a slightly different trajectory that's somewhere in between this. So I'm sort of a hypocrite here because last night we had a conversation about visions. We said, yeah, we should tell people sort of go this trajectory, this trajectory. And I immediately said, we got to stop giving people 2 trajectories because the answer is in the middle somewhere. But I did exactly what I said not to do. But I'll say it in words is that understanding these trends is what gets us into the instead of into 2. Because neither of these is realistic. I don't think. And that brings me to my last admission here. Dave is in the front row. So as I was looking through some emails to find the agenda for this and all that kind of stuff, I found this email from a guy I met 2 years ago at the symposium, who emailed me after we left, asking me to explain what I thought the future would look like in 42 years. I didn't respond to this. And I'm still not sure. And now I'm going to give it to Dylan.
That was a pretty smooth exit. We'll have a time for a question if anybody has a complicated thing. The one thing I will point out on the slide, the Shoals Club was built right after that trajectory went to its peak. So that's, it's a timing thing, but it's like the dynamics there are just amazing. And people that live here, you see it all the time. Yeah, Scott, you got a question for Joe?
Having been here for a while, to me, it's the strength from the wind speed, direction wind, when it comes to hurricanes, it seems to move the most.
I can't remember, you guys had a meteorological station in the island for a while, right? And how long back did it go?
Yeah, about 14, 13.
Those are the individual characteristics, like to really understand that storm piece, we did it just by track, but you're right, it's, you know, we talk about radius of where the track is, but the radius of a storm is very different. So there's a lot of details that they get to, and I agree with you.
Yeah, and like nor'easters, I mean, the ones we've had, from those, I mean, there's a lot of, but it's such a dynamic system now, right? And it'd be an incredible ask to have Joe come up here and go, here, we figured it out. So next year he will, but anyway.